clapping. Give one more round of applause. One more round of applause. Some incredible speakers, and thank you for that wonderful information. Our next speaker we're bringing up is Chip Albright, a 40-year tenured professional in the fume hood business. So do we have any laboratory fume hood involvement, folks? 1, 2, 3, 4, 5, 6. Good, good. Thank you all for being here, and thank you for Kanomax for having us. Fume Hood Certified is excited to be here. And again, we're bringing up Chip Albright, the author of Laboratory Fume Hoods Explained, a very popular book. He's also the author of many online course curriculums for studying fume hoods, studying fume hood testing, things just in basic fume hood performance and function, online curriculum. And lastly, Chip is also the inventor of not one but 2 brand new fume hood testing products, one of which I'm sure you'll hear a lot about, Tri-Colored Fume Hood Visualizer. We're very excited about what's happening in the fume hood testing world. Chip is very much at the front of it. We're very fortunate to have him talk. Listen up, here we go, give him a round of applause.
Well, if you hadn't figured it out, my involvement is particularly in science labs. And I tend to specialize in lab ventilation with an emphasis on fume hoods. And, you know, one of the things that quite frequently comes up is, you know, what is the indoor air quality in the lab? Because we have a lot of contaminants. And we also have another issue in that when fume hoods lose containment, they pollute the indoor air quality. So the question is your lab lung friendly? Well, that's a pretty difficult situation to answer. But by looking at the entire lab ventilation system in a holistic way, we'll be better prepared to answer that. And I won't repeat it because Matt and Luke have already said a lot, but you know, the thing that I saw in all the thousands of labs that I've been into is that most of the time the people working in the lab really are unaware of the hazards and the potential damage that they can cause. So back to the question, is your lab lung friendly? Well, let's talk a little bit about air. Basically, we know that fresh air is important. You just heard, you know, cities like New Delhi that have horrible air really have a huge impact on the health situation. It's pretty well documented that air pollution is bad on your health. You can see from these 2 illustrations that, you know, one situation looks very bad, the other one looks pretty decent. So we need to start thinking about indoor air quality the same way we think about outdoor air quality. So when your fume hood isn't working, there's loss of containment. And the fugitive chemicals pollute the lab air and exposes the lab occupants to potentially harmful chemicals. Labs are dangerous. They have a lot of hazards. But what we're really talking about today is exposure. Many of the materials we work with give off hazardous contaminants, whether they be fumes, mist, vapors, particles, aerosols. A few chemicals are visible, but most are invisible. But if you can smell chemicals in your lab, you've got a problem. This is a real lab at actually a very well-known pharmaceutical company in India. And you can see how the loss of containment and the pollution in the lab has just totally destroyed it. Look at the hood, look at the casework over here. I mean, it's so bad that the doors have fallen off. The drawers don't have drawer heads. I mean, it's really bad. And yet, when I asked the investigator, the PI, you know, aren't you concerned about this? He goes, well, it's not that bad. So, you know, if it's doing that to your furniture, what's it doing to your lungs? So, if bad air is damaging the furniture, you can imagine it's also damaging the body. But beyond the body and the users, if you have polluted air, you can also compromise the results on the work you're working on because it tends to be a contaminant. So fume hoods are a safety device, but without proper testing to verify containment, they could be unsafe. So is my fume hood working safely? Maybe. And it's really all about the air. So we really have to pay attention to what the air is doing. You've heard comments already tonight about, you know, the effectiveness of filtration, about what happens when the air quality isn't a lot better. But a lot of people, we find, don't fully understand air. And air is a fluid, and it behaves under the laws of fluid dynamics. And so it's going to behave quite similar to water, where water runs downhill, air runs from high pressure to low pressure. So it's all really about how the air moves. Now here's a case, this was when we were shooting the cover of the book. You can see that in this case, smoke or fog is coming out of the hood because the pressure on the outside of the hood is less than the pressure inside the hood. So how can we validate containment? And we're going to show you a product, Tricolor, which is kind of unique. So exactly what is loss of containment? We'll take a quick look here and see. So what does it mean when we say, is your hood working? So what we're really asking is your hood containing? Because if a hood is also an exposure control device, and so we're trying to protect the users in the lab, the occupants of the lab, from being exposed to potentially harmful chemicals. And just because you have a fume hood doesn't mean it's working properly. There's a lot of hoods out there. Some estimates are as high as 70% that aren't properly containing. So we really need to be able to validate containment. And if we could see air currents and we could see chemical containments, fume safety would be a matter of common sense. But because we're dealing with things we can't see, it's very hard to understand what's really happening. So 3 years ago, excuse me, we invented a product called Tricolor. And what Tricolor does is it uses haze, which is diluted fog, and lasers. And so we release the haze inside the hood. And then we have lasers that look on the back side of the sash and the front side of the sash. So there in this shot where you see the green, that's where the contaminants have come out of the hood and are crossing the green laser. So that's basically loss of containment. So with the Tricolor Airflow Visualizer, you can actually see what's happening. Most people don't appreciate it, but hoods are very turbulent. If they were more laminar, we wouldn't have as much loss of containment. But because of the turbulent nature of the products, we do. So basically, one of the interesting things, probably the most common standard here in the United States for testing hoods is AHR 110. And it says in the standard it's not a safety evaluation. So really to have a safety evaluation, we need to look at containment in a more dynamic situation and less static like AHR does. So watch the vortex there collapse, and when the vortex collapsed, then you saw the loss of containment. So it's that instability of the air inside the hood that's the problem. So now we're going to have a technical challenge. The next is a video with Sam. Let's see if we can get it.
Well, this is how tricolor works. Smoke ejects from the tricolor unit, and with the red laser behind the sash, you can see exactly how the air inside the hood is behaving. Have you ever actually seen the air as it's floating around and moving inside of your hood? Without tricolor, air is invisible. But now that you can see it, look at it. Take notes. Observe it. Does the airflow seem smooth? Does the airflow seem turbulent? Is the air behaving differently on the left side of the hood than it is on the right side of the hood? What can you learn just by watching the air behavior? With the red laser, you can observe and educate yourself on what's going on with the air that's inside of the hood. With the green laser that's placed on the outside of the sash, anytime fumes or air escape the hood chamber, you'll be able to see it light up in bright green. That means that a poorly performing hood may have many consecutive green flashes, and when performing the tricolor challenges, you'll find that it's easy to pull the smoke out of the hood and for it to get exposed with the green laser. This also means that a hood that's containing well may not have any green smoke flashes at all, or just minuscule flashes of green smoke showing small micro failures. And you'll find that when testing a hood that's actually containing really well, that even when doing the tricolor challenges, that it's hard to get the air to exit the hood and to light up green. So when you're testing a hood and it looks like this, with no green smoke, that hood is performing well and will likely receive a good rating. But if you're testing a hood that has constant flashes of green smoke coming out of the hood chamber, and you're having even more loss of containment when doing the tricolor challenges, you can be sure that that fume hood is not containing properly, and whoever uses it will be at risk of exposure to breathing chemicals. A hood like that will fail its safety test and should be troubleshooted and repaired immediately.
So now we're going to look at one of the real misconceptions is that there is a direct relationship between face velocity and containment, and there isn't. Face velocity is a factor of containment, but there is no direct relationship. So I probably personally tested 6,000 to 8,000 hoods, and I would say over half of them that failed FS6 containment testing had really good face velocity. So face velocity is face velocity. It tells you how fast the air is going in the hood, but it doesn't tell you if the hood's working.
Tricolor is a major upgrade from face velocity testing. Some testers will certify a fume hood is safe based solely on a face velocity profile. There's a major misunderstanding about face velocity. Many assume that if a hood has a certain face velocity, that it's properly containing, and this is simply not true. Take this hood for example. It's showing an acceptable velocity reading of around 100 feet per minute, yet the hood isn't containing any smoke at all. Why? Because there's no direct correlation between face velocity and containment. I'll say that again. There's no direct correlation between face velocity and containment. For more on this, watch our YouTube video about the myth of face velocity. So we are simply building on top of the ASHRAE 110 protocol because a full-scale tricolor test still includes a face velocity profile and a small smoke or local smoke visualization test. But tricolor takes containment testing to a whole new level, so you can be sure that your hood is performing and containing safe. With tricolor, the proof is in what you see.
So in our protocol, we have 8 real-world challenges, and I'll walk you through each of them just so you can see. That's one of the challenges. I've been doing a lot of international work. I quite frequently am asked, which is better, ASHRAE 110, the American standard, or EN 14175, which is the European standard. And my answer is neither, because they're testing different things. And so what probably the best component of the EN standard is that they do have a simulated walk-by that goes back and forth across, whereas the only dynamic thing in ASHRAE 110 is sash movement. So we do a rapid sash movement. So let's look at each of the 8 challenges.
The full open sash position is for setup only, but we want to see what the hood is doing in its worst sash position. So raise the sash to full open and just stand back and observe and see what's going on. Notice the red smoke behind the sash at the top of the hood. See what it's doing and see if you can find any green flares of loss of containment. Here's an example of a poorly performing hood with its sash fully open. You can tell that smoke and fumes are definitely lazily making their way outside of the chamber into the breathing zone. That's an indication that the hood is performing poorly. The design opening is the working height that the system was designed for. It's often around 18 inches, and many hoods have sash stops at the design position. So lower the sash to the design opening, take a few steps back, and just observe and watch to see if you can find any loss of containment light up in green. Here's an example of something like a cross draft affecting a hood at its design opening. Cross drafts could come from many different things. You definitely don't want to see this much green smoke coming out. Containment is greatly impacted by the air balance of the room. Opening and closing the door causes the room balance to change. For the lab door challenge, just go open and close the lab door. See if the red smoke behind the sash changes in any way. See if any green loss of containment comes forward. Removing items from the hood can cause chemicals to follow that item out of the hood. For this challenge, you just want to grab any piece of equipment, set it inside the hood, and pull it out. See if you can get any green smoke to follow it. Moving large items will make a hood fail more so than moving small items like a beaker or a stand. But you definitely want to try a few different items and observe for any loss of containment. A person standing in front of the hood creates turbulence that can draw chemicals out of the hood. So all you want to do for this challenge is walk right up to the hood and just stand there. The fume hood is pulling in air from behind you. So when the air goes around you, it can create a low pressure zone right in front of you. That can cause reverse flow and pull chemicals out of the hood. So you want to be watching directly in front of you to see if any green loss of containment comes from you standing in front of the hood. On a failing hood, you can see that somewhat sheet of lazy smoke definitely coming out and into the breathing zone. The walk-by challenge, you can almost always get at least some loss of containment, even from a hood that's performing really well, by doing a walk-by challenge. To perform the test, you want to have somebody walk right in front of the hood at a brisk pace, maybe at a slow pace, go to the left, go to the right, just walking by and causing turbulence in different ways to challenge that hood to see if it can keep the fumes in its chamber. Sometimes you can get a better view of the smoke and how it behaves if you stand slightly to the side of the hood as opposed to right in front of it. Here's an example of failure from a poorly performing hood, and you can really tell that it sucked some of those fumes right past the green light and lit it up. Definite loss of containment there with the walk-by challenge. Rapid movement inside the fume chamber can make the air turbulent and cause a loss of containment. To do this test, just approach the hood and move your hands around as if you were working. You might reach to your left, you might reach to your right, you might cup your hands and see if you can pull air out of the hood. If you're not getting a lot of green smoke, that means your hood's doing a pretty good job at containing. You'll see on a poorly performing hood that hand movement can definitely cause loss of containment. This is why you always want to move slowly and deliberately when working at the hood. Again, you might get a little better or a little different view if you stand to the side. Opening and closing the sash can cause loss of containment, especially at the edges of the sash. So we do a rapid sash movement challenge to see if movement from the sash will pull air out of the hood and light it up in green for us to see it. Observe what the red smoke behind the sash is doing and watch for any green loss of containment. On a failing hood, notice how we can see the loss of containment when the sash moves up and then stops. It's kind of lazy, it's kind of small, but it is still chemicals that are exiting the hood into the breathing zone, and we want to prevent that. Again, you might get a little better or a little different view if you stand to the side. This can be a tough challenge to perform because you just need to make sure that you have all of your tricolor laser cords pulled to the side and not tangled up with each other when you're raising and lowering the sash.
So, quite frequently we like to say that if you can't see a problem, you can't fix it. And this product is very visual. I get asked all the time, why is green on the outside and not red? And the reason is that the green laser is more contrasting. So we can see smaller amounts of containment loss with green than we can with red. So if you want your hood to be safe from bad air quality, you could, or if you want to be safe from bad air quality, you could dress like this. Or you could have your hoods tested and address any of the performance issues. So anyway, just wrap this up. Kanomax sales tricolor. If you have questions about it, want to learn a little bit more about what we do, come see us at the booth or stop me afterwards. So thank you very much.